This is CPM Calculus Chapter 5, number 42. So the second derivative test is easy to apply once you found the second derivative. Okay, it is pretty easy. You just take f double prime at the zero you're looking at. If it's positive, concave up, negative, concave down, that would be a minimum, that would be a maximum, right? But unfortunately, it does not always work. That is true. We're about to investigate. The first derivative test works more often, but is harder to apply. That is true. We have to look at all of the regions, right, and compare them. Let's compare the two tests by investigating the graphs of y is x squared, y equals x cubed, and y equals x to the fourth at the origin, right here at x is 0. Use the first derivative test to investigate the behavior of y equals x squared, y equals x cubed, and y equals x to the fourth at the origin. So let's start with y is equal to x squared. First, we're going to take the first derivative, and then we're going to, the first derivative is 2 times x, and we're going to set this equal to 0 to find the zeros, right? The critical points are the zeros where y prime is equal to 0. So 2x is equal to 0. Divide both sides by 2. You get x is equal to 0 is a critical point. Alright? So the first derivative test has us draw a number line, place our critical points on it, and then check the regions to the left and to the right. By plugging in values into y prime, into the first derivative. So to the left of 0, I'm going to choose easy numbers. I'm going to choose -1. To the right, you can choose any number you want. To the right of 0, I'm going to choose 1. So when we plug in -1 into 2x, we get 2 times -1, that's -2. But we don't care about the value, we just want to know if it's positive or negative. Because negative here tells us that the function is decreasing. Okay? Negative means decreasing. So I'm going to just draw decreasing right here. Right? That's a decreasing segment. Plugging in 1 into our y prime, we get 2 times 1, that's 2, but we don't care about the value, we just care that it's positive. And that tells us that it's increasing. So decreasing to the left of our critical point, increasing to the right, tells us that this is going to be a minimum. Right? This tells us that at x equals to 0 is a minimum and let's move on. Let's look at the equation y equals x cubed. So the first part we always need to do is find the derivative, that's 3x squared, and then we want to find the critical points, okay, CP, and that's going to be y prime is equal to 0, which is 3x squared equals to 0. Solving for x, let's divide both sides by 3. We get x squared is equal to 0 over 3, or 0. Square rooting both sides, we get x is equal to 0. Again, we plug in our critical points onto the number line, and then plug in points to the left, -1, and to the right, 1, and every other region or interval, plugging them back into y prime. So -1, when we plug it in, -1 squared is positive 1 times 3, makes this positive, which means it's increasing. Plugging positive 1 into x makes this 3 times positive 1 squared, which is also 3, which is positive, which tells us it's increasing to the left and increasing to the right, which tells us nothing, right? So we don't learn anything about our extrema, about our maximums and minimums from the first derivative test. Finally, we have y is equal to x to the fourth. Take y prime, the first derivative, that's 4x cubed. Set this equal to 0 to find our critical points. So it's 4x cubed equals to 0. Divide both sides by 4, we get x cubed equals to 0. take both sides to the power of 1/3, we get x equals to 0 to the power of 1/3 or 0. So we're going to put all the zeros on our number line, look to the left. I'm using pretty basic numbers, -1 and 1. Plug those back into y prime. -1 cubed is still -1 times 4 is -4. So that means it's negative decreasing. Plugging in +1, we get +4. That means it's positive increasing. So that tells us that 0 here is a minimum. At x equals to 0, we have a minimum. Alright. So now we found out information from the first derivative test, right? The first derivative test shows that y is equal to x squared has a minimum at the origin, and y equals to x to the fourth has a minimum at the origin, but y equals to x cubed does not have any local extrema, right? We don't learn anything about maximum and minimums, so there are no local extrema at the origin, right? No max, min at origin. Alright, so part B, we want to re-look at all of these, confirming our results. We want to try to confirm our results that we just found with the second derivative test. Okay, and then we also want to answer when does this test work, and what can we conclude if you know that the second derivative equals 0 at the origin. So also, what does it mean if the second derivative at 0 equals to 0, right? This is where your 0 is. So what does it mean if f prime of wherever your 0 is equals to 0? So let's confirm this information if we can. So let's go ahead and start with y is equal to x squared. We already found our critical points, right? Critical points. Up here we found the critical points. They're all where x is 0. So I'm going to just say critical points are at x is equal to 0. So then we go ahead and look at y double prime. So y double prime is taking the derivative of 2x, which is 2, right? And then we go ahead and again draw our interval, our number line, placing 0, all of our zeros from the critical points, which was just from the first derivative. Okay. Then we look, what is y double prime at x equals to 0? Well, at x equals to 0, y double prime, what is it? It's 2. It's always 2. So it's still going to be greater than 0. So y double prime is positive here, right? So what does it mean when double prime is positive? That means our function is concave up, right? And that means 0 here is a minimum. So we've discovered using the second derivative, or we confirmed, that at x equals to 0 we have a minimum, right? Now let's go ahead and look at y is equal to x cubed. We have our critical points from above at x equals to 0, right? We have y prime equals to 3x squared. So then we have y double prime is equal to 6x, right? So let's go ahead and plug in onto our number line all of our critical points, 0, and at x equals to 0, at x equals to 0, y double prime is equal to, well, now we have to plug in x is equal to 0. And what does that tell us? The second derivative is 0 at the origin, but this doesn't tell us anything. If it's not positive or negative, if y double prime is not positive or nor negative, then we have inconclusive results. Right? This means we don't know. We know already that from part A, there are no maximum or minimums at the origin. We don't learn anything special about them because there are none, right? Except none. We don't learn, well, I better erase that. We do learn something. We learn that there are none of them, right? Let's erase this whole thing because we learned that there are none from the first derivative test. Since it's going up, there are no maximums or minimums at the origin. But here we have inconclusive results, right? So let's go ahead and look at y equals x to the 4th. Remember, our critical points from part A were x equals to 0. For all of these, our critical points happen to be x equals 0. This one, y prime, was 4x cubed. Y double prime is equal to 12x squared. So let's go ahead and plug in all of our zeros on the number line. It just so happens to be 0. At x equals to 0, y double prime is what? Well, you plug it in there, it's equal to 0 again. So the same thing, if y prime is not, if y double prime is not, is not greater than or equal to 0, or y double prime is less than or equal to 0. So if none of these are true, then we have inconclusive results. Right? Both these two functions told us inconclusive results, right? But we know from part A that there's a minimum at x equals 0 for x to the 4th, and we know that there are no maximum or minimums at the origin for x cubed. So this second derivative test isn't very helpful, right? What does it mean if f double prime of a is equal to 0? Well, this means inconclusive, right? This is what I meant earlier when I said it doesn't tell us anything. Right? If the second derivative equals to 0, that means we don't know if it's a minimum or not a minimum. Okay, so this again was not inconclusive. We know that there are no maximum or minimums at the origin here because it's increasing to the left and to the right. Alright? Alright, so this ends the problem, but just for fun, let's go ahead and look at these three graphs to see our hard work. So we know x squared, right? Let's graph it anyway, is just a parabola. Right? And we can see that there's a minimum at the origin. Let's also graph x cubed. X cubed. And we can see there are no maximums or minimums, right? This function is always increasing. We do have an inflection point, which we didn't talk about, right? This right here does tell us that since it's increasing to the left and to the right, there are no maximums or minimums, but it does tell us that there's an inflection point, right? Finally, let's look at the graph of y is equal to x to the 4th, and we have again a minimum at the origin, which is confirmed by the first derivative test, but not confirmed by the second derivative test. So that's going to end for us looking at CPM Calculus Chapter 5, number 42.